Hello everybody and welcome to our videos on the review of trigonometry. So we're going to spend a little bit of time looking at chapter 8 about trigonometry before we go into derivatives. The first thing to know is about arc length and sector area. So when we deal with a circle, which is how we're thinking about trigonometry now, we need to know some important definitions. We know that the center of the circle is that point that's right in the middle. Radiating out from the center to the edge of the circle is the radius. If we sweep the radius through an angle, we make a sector. The area of this shape is called the sector, and it looks like a pizza slice. And if we imagine that there was like a marker at the end of this radius and it was tracing a line along the outside of the circle, the perimeter that it traces is called an arc. Okay. On the other hand, if we cut a line through a circle, but it does not cut through the center, we call that a chord. And the piece that it sections off is called a segment. Now, when we use a chord and make a segment, we might have a minor segment. We might be interested in the minor segment or the major segment. Minor because it's smaller, major because it's larger. And the minor segment has a minor arc, that's the smaller arc. And the major arc is the arc around the major segment. Now, one of the things you might be asked to do is to calculate arc length. And arc length is usually called little l, and it's the distance that a radius sweeps through as it moves through an angle equivalent to theta. So the formula for arc length has to do with comparing the amount that you swept through with the radius compared to the whole circle. Okay, so if we consider the arc length is L compared to the whole circle, which has a circumference of 2 pi r, and the angle that we sweep through for the arc length is theta, the angle that we sweep through in the whole circle is 2 pi radians, then length is equal to pi times radian. Length is equal to theta times r, okay, where r is the length of the radius. And if we want to change that theta to degrees, then we would just divide it by 360 and multiply by 2 pi r. Remember that if we're changing an angle from radians to degrees, we would multiply by 180 over pi, and if we're changing an angle from degrees to radians, we'd multiply by pi over 180. We can also calculate the area of the sector, again by using a comparison, a ratio, comparing the area of the sector to the whole circle, and the angle that you swept through to the angle to go all the way around the circle, which is 2 pi radians. And we get area is equal to 1/2 theta r squared. And again, if we want to change that theta from radians to degrees, we would multiply our angle by 180 over pi, or use the formula that they've shown here. Okay. So just a little review here. Degrees to radians, we multiply by pi over 180 because we're trying to get that pi into our expression. For radians to degrees, we multiply by 180 over pi. Okay, so just one quick example here. If I want to change 300 degrees to radians, I would multiply by pi over 180. I get 300 pi over 180, and I would divide both sides to get to my reduced form, which is 5 pi over 3. If I wanted to change radians to degrees, I would take my radians and multiply by 180 over pi. And that would mean I would cancel out the pi's, and I would simplify the fraction. Okay. Remember that if you get confused, remember that if you're multiplying pi by pi and getting pi squared, you're not doing the right thing.